Hello, back with Professor Sims. Today, Sim Slays multiplying radicals. Let's look at our rule for multiplying radicals. When you multiply radicals, as long as our index is the same, and that's why I have the lowercase n to indicate same index, you just simply multiply what is under the radical. Multiply what is under the radical. So for an example, if I have the square root of 2 times the square root of 3, and again we note that our index is the same here. They're both are 2's. That's why we say square root. The square root of 2 times the square root of 3 is equal to the square root of 2 times 3. Multiplying our 2 times 3, we have the square root of 6 is in its simplest form. It doesn't have any perfect square factors. So we will leave that as the square root of 6. Let's try another one. What if we have the square root of 12 times the square root of 3? Again, our index is the same. That's the square root of 12 times 3, which is the square root of 36. Now, 36 is a perfect square, so that can be simplified. The square root of 36 simplifies to 6. Not square root of 6, 6. Let's try another example. Let's say we had 2 times the square root of 3 times 3 square root of what? 5. To multiply these radicals, and again we make note that the index is the same, but we're going to this time multiply what's in front of our radical symbol and what is under. So here we would have 2 times 3 on the square root of 3 times 5. Multiplying 2 times 3, we have 6 times the square root of 3 times 5, which is 15. This is in its simplest form, folks. We cannot simplify the square root of 15. And of course, our order of operation tells us that we would have to find that decimal value for the square root of 15 before we would multiply it by 6. So that is in its simplest form. One more, maybe two more. Let's say if we had 5 on the square root of 2 times 3 on the square root of 6. And we're multiplying these radicals. Here again, index is the same. So we want to multiply 5 times 3, multiply what's in front, which is 15, and 2 times 6, which is what? 12. Now, square root of 12, that can be simplified because 12 has a perfect square factor. So let's simplify the square root of 12. The square root of 12, and recall again, folks, this answer reads right now, 15 times the square root of 12. So to simplify the square root of 12, the biggest perfect square factor of 12 is 4. So we will rewrite square root of 12 as square root of 4 times 3. So now this becomes 15. I'm going to put the little dot here for that multiplication. Square root of 4 times square root of what? 3. Well, we know 4 is a perfect square, so we can take the square root of it. The square root of 4 is 2. Now look what we can do here. We can multiply now the 15 times 2, and we have our final answer of 30 times the square root of 3. One more example I want to share with you today. What happens if we have variables inside our radicals? If we have variables inside our radicals, the same rules apply. Let's say if we have the square root of 2x times the square root of 3x squared. This will equal to the square root of multiplying what's under the radical. 2 times 3 is 6. We recall when we multiply those variables, we add the exponents. So that's x to the what? Third power. X cubed can be simplified because, yes, it has a what? Perfect square factor. So let's rewrite this as 6 times x squared times what? X. And the square, this which becomes the square root of 6 times the square root of x squared times the square root of x. And the square root of x squared can be simplified. That is x. So we will rewrite our final answer as, we will bring that x in front on the square root of 6 times the x. And that will conclude our session on multiplying radicals.